Jagdish?
Yes, sir. I think we can start now.
Yeah, we can start.
Okay.
Already 10 minutes delay.
Yes, sir. Very good morning, all the participants, respected Aaron Chouhan sir and respected Bal sir. Welcome back for the second day online conference on AMEIIM 2022. Now we have with us industry expert, Mr. Aaron Chouhan. Before his talk, I would like to introduce him. Dear participants, Mr. Aaron Chouhan is a senior principal scientist and HOD at downstream at Jawaharlal Nehru Aluminium Research, Development and Design Center, Autonomous Body, Ministry of Mines, Nagpur. He has earned his BE in Metallurgical Engineering in 1998 from GEC Raipur, now it is NIT Raipur, and he earned MPhil from IIT Kharagpur in the year of 2000. Since June 2000, he is working as a scientist in downstream processing department of Jawaharlal Nehru Aluminium Research Development and Design Center, Nagpur, and contributed in various research activities related to downstream processing of aluminium. Various projects on DC castings technologies of aluminium alloy have been successfully accomplished for primary and other aluminium industries. He is working in the field of structural property, correlation, characterization of cast products, work development, resource efficiency in aluminium. He has completed more than 13 R&D projects for aluminium industry, and research institutes for him is AMEIIM for spectrochemical analysis. He is also associated with various activities related to resource efficiency in aluminium, non-ferrous metal recycling framework, and Bureau of Indian Standard Metal Recycling Authority. He has also got a patent and improved heat treatment process for production of heat resistance aluminium zirconium alloy wire for overhead conductor.
For the kind introduction, and dear students, all faculty members, Dr. Jagdish, Dr. Naidu, as organizers must have circulated topic of my talk, that is circular economy in non-ferrous metal sector, Indian perspectives. Before I start my talk, I would like to thank the organizers for inviting me to deliver this talk on this forum, especially when the country is in the transition phase with regard to the production systems, or it is turning or moving towards the sustainable, more sustainable production systems. So it is, I thought that it could be a right time or opportunity for me to share some thoughts or information about this sustainable production or circular economy, and share what is going on in the country, and which would ultimately affect how the materials are used, how the production systems are used. And that is why I picked up this topic of circular economy, and I'll be sharing what exactly is going around in the country. Before I start showing my presentation, I will try to give you some analogy or some aspect of circular economy. Like this circular economy, resource efficiency, sustainable production and consumption, these are not very new words. But in the very recent time, maybe you noticed that when this pandemic started sometimes back in 2020, all the countries started closing their borders, their doors for their neighbors. Even the district borders were closed, even the city borders were closed, even the state borders were closed, country borders were closed. Think of a situation where the countries close their borders for material supply. What will happen in that situation when we are dependent on other countries? We say that we are a globalized nation, or the whole world is globalized. But this pandemic has shown that whenever there is a crisis, we try to protect ourselves and we go into the deglobalization mode. So this deglobalization mode has made the government think very aggressively about this circular economy or resource efficiency, because ultimately we have to be dependent on what we have. We cannot be dependent on what others have. Ultimately, as day may come, like the war between Russia and Ukraine, that the news is going around, and see the situation, presume the situation, what will happen to the material supply system. Some resources are there with Russia, some resources are there with Ukraine. If they don't exchange the resources, ultimately they have to live there with their own resources. So the moral of what I'm trying to convey is, like, we have to be dependent, or we have to use our resources in such a way that we are not much or dependent on the resources from other countries. So that is the basis of circular economy. Let me share my presentation, and before I talk very specifically about the circular economy, or what is happening around in the country, I'll just give the brief about this institute. Dr. Naidu, could you please confirm whether my screen is available to you?
Yes, sir, it is available.
Okay, thank you.
Yeah, it is visible.
So just brief introduction about Jawaharlal Nehru Aluminium Research Development and Design Center. We are located in Nagpur. This institute is an autonomous research center under Ministry of Mines, Government of India. It was set up on paper in 1989, but became fully functional 1996 onwards. And in 2021, we completed 32 years of commendable services to the aluminium industry. Our vision is to be renowned nationally and globally as a primary research hub for all aluminium products and processing. Mission is to undertake innovative research projects for providing complete technological solutions to meet the challenges for sustainability of aluminum industry. And objectives are to undertake research for material and energy conservation, impart training to aluminum industry, provide technological assistance to both primary and secondary aluminum industry, and assist industry in assimilating and adapting the technologies or the know-how for production of aluminum and the aluminum products. As the name suggests, Jawaharlal Nehru Aluminium Research Development and Design Center, we work on all aspects of aluminum, right from the bauxite, that is the ore for aluminum, to the modern techniques or the emerging areas like waste utilization, energy conservation, or the environment management. Expertise-wise, in the bauxite domain, technological evaluation, beneficiation, petrography, alumina technology, special alumina. Smelter that is Hall Herald process. We work on instrumentation, cell monitoring, smelter processes. In the metal side, casting and forming of aluminum alloys, alloy and product development and characterization. We also provide world-class analytical services to our aluminum and the ancillary industries, and our chemical and mechanical testing or the services are ISO 17024 2017 accredited, and very soon the metal division will be accredited with 17034 standard, that is for reference material producer. We have 4 technical divisions: bauxite, alumina, aluminum electrolysis, analytical, downstream. 3 interdisciplinary groups, say energy, environment, and business development. We have limited staff. You can see on your screen, 18 scientists, 10 administrative staff, and 23 scientific and technical staff. And we also recruit contract staff, say like junior research fellow, senior research fellow, and supporting staff depending upon our workloads. Since 1996, we have been carrying out various services and projects for the industry. We have completed more than 100 industrial projects, more than 30 projects for government, Ministry of Mines, patents 22 we have filed and 6 are granted. And our research work is also published in various international and national journals. And we organize many seminars and workshops relevant to the aluminum industry. Some of the key assignments from the government side: we are currently working as a metal recycling authority, economic study of aluminum recycling, resource efficiency in non-metals and non-ferrous metal sector, and we are also part of Inter-Ministerial Committee for Import Substitute in Aluminum Industry. For Niti Aayog, we are working on rare earth extraction from the industrial waste like red mud and fly ash. And we also have published a strategy paper on resource efficiency in aluminum sector for Niti Aayog. So the title of my topic, the key word or the catchword is circular economy. What is circular economy and why should we adopt or create a circular economy? Remember, we do not inherit the earth from our ancestors. We borrow it from our children. Our ancestors have not left this earth to exploit it the way we wish or we want, consuming all the resources. You can consider ourselves as a guardian of this earth or this nature, and whose future guardians are awaiting. And if we consume all the natural resources, leaving only guardianship to the future generations, it will be very, very kind of unfair from our generation and our side. So the resources has to be shared with the future generations as long as possible. So this creates the basis or the concept for circular economy, or you may say resource efficiency. So it is a concept where we use the resources. When I say resources, it is natural resource more efficiently across their life cycle by closing, extending and narrowing material loops. And even we say like the transition to circular economy from linear economy may lead to decoupling of extraction of natural resources with economic growth, and expected benefits of circular economy transition. So circular economy, I use the word linear economy. In a simple definition or simple explanation of linear economy would be like you take the material from nature, use it for your requirement, you make it a product or so, and at the end of life, you discard it or dispose it. But when you say circular economy, the third aspect, dispose or discard, is not there or should not be there, or it has to be very, very minimum. That means the loop is complete, which I will again be explaining in the subsequent slides. So reduce extraction of natural resources, lessen exposure to geopolitical supply risk, like what I mentioned when I started talking, like this pandemic-like situation or the war-like situation, reduced environmental pressure, new economic and employment opportunities, synergies with the low-carbon transition. And circular economy requires the utilization of resources in economy through repair, reuse, refurbishment, and remanufacturing of end-of-life products. That is why I said that the third point or the third activity in the linear economy, where you discard the product. Okay, this pen is not working, put it into the dustbin. No, let us try to repair, let us try to reuse, let us try to refurbish. And if at all not possible, the pen will go for recycling or the remanufacturing. Recycling of post-consumer materials, what I said, like the pen, and waste into secondary raw material. So a Renault pen which we use, say, the plastic can be recycled again to make a new pen or some other product. Product service systems and extending material loops through eco-design. Here the new concept is coming where we don't own a product. Product will be served as a service. Just for example, say, like we are always tempted to buy a new mobile phone whenever a new model is launched with improved specification, maybe a 120 megapixel camera with 120 GB RAM, or larger screen, or even the whatnot, like the specifications of the mobile phones. If you see, if you compare it from the 2000 time and then today's 20 years later, you'll find the mobile phones have changed a lot. And during this time we have purchased numbers of phones, and I don't know whether we have discarded, given it to somebody, exchanged it or so. But in future it may happen that the mobile phone will not be sold, but it will be given as a service, so that you use the mobile phones as long as you wish, and once your contract or your you want to change, you go back to the mobile seller, give it the mobile phones back, and they take a new with the new specifications. So the mobile phones are just an example. Even it can come for many products where the products will be served as a service. Even the European countries, they started selling the clothes as a service. You rent the clothes, you don't buy the clothes. You take it for 6 months, use it, return it to the seller. And then narrowing material loops through resource efficiency initiatives means you don't use multi or many materials, you try to minimize the material usages. So ultimately the circular economy is trying to mimic or copy the natural system. Like this left side is a biological process and right side is a technical process or technical cycle. So if we take anything from Mother Earth, biological cycle, like a plant, a tree comes up, the grows, it uses nutrients from the earth and grows, and at the end of its life it is disposed in Mother Earth and then giving back nutrients, and in the process none of these the biological products degrade or harm the environment. But when we do we produce material, we harm the environment, we produce the waste which cannot be used. So the circular economy, the basic concept is to adopt or mimic this natural processes, and it is called like cradle to cradle thinking, where the biological system, you have what I said earlier, like the plant grows, the leaves, everything, ultimately it decomposes, then again grows, and here no waste is generated. If we can have the technical life cycle of products where we manufacture, use it, and ultimately again we do the de-assembly or the waste separation and try to generate new material or new products from it. So this is the cradle to cradle thinking for basis for the circular economy. And then industrial symbiosis is another term where the waste generated by one industry can be the raw material for the another industry. Like the slag generated by steel industry is the input for the cement industry. So there is a kind of industrial symbiosis where the waste has some utility, and it doesn't degrade or harm the environment. Then another example of biomimicry is like, if you see on your screen, this is the wing of an aeroplane, and it has some similarity with the an eagle or some flying bird. So the nature is providing solution for many of our problems. So if we try to mimic the biological system or the nature's thing for our industrial system, our requirement, probably the harm to the environment will be minimized. Here there is a building in the Zimbabwe called the East Gate Center, and this is based on the mimicking the termites mound, like how the termites keep their mound or their house cool. The same concept has been used to design this building, where no air conditioning is used to cool the building. That means the less electricity and the less harm to the environment. So these are the three bases or the things which is kind of example or the concept for the circular economy or the resource efficiency. So in resource efficiency or the circular economy, which I'll again try to define what does it mean, you try to reduce the environmental footprint, generate increased income, reduce the resource dependency, and also minimize the waste while recycling and collecting and all this activity. If you try to simplify the definitions, you take the material from the Mother Earth, make whatever you want, and here delete this part, go for recycling, and whatever energy you require to produce the material, use the greener sources of energy, so there will be no waste as well as the environmental harms. So this is the basic concept of circular economy, and this paper is was published in 2021, where someone has done the modeling of material consumption, how in 2100 material demand will go like. So you'll see all the material, there is increasing demand for material with increasing population. If you see the vision of Government of India, like government wants to enhance the share of manufacturing in GDP to 25% in 2000 by 2025. Then World Economic Forum has done some study, like what will be the future consumption in India. Like there is a driving force, number one is income growth, urbanization, favorable demographics, technology and innovation, evolving consumer attitudes like the consumerism. There is a terminology called consumerism, and it is also observed that the consumerism tendency is increasing in India, and by 2030 we will require this this 4 times growth in consumer spend. That is what is predicted in this document, and accordingly the government system, some say from the Niti Aayog, says that India needs to grow about 10% annually for the next 3 decades to be able to meet the ever rising demand of its growing population. The new scheme or the new vision, Gati Shakti, from our Honorable Prime Minister Sri Narendra Modi, where lots of infrastructure or various schemes are being being brought to a single platform to boost up the manufacturing in the country. So all these activities, our government's infrastructure plans, government's growth plans, economic growth plans, then our own needs of like being consumer, we want new TV, we want new mobile, we want new devices. All these will require lots of material and decreasing poverty. So where this material will come from? That is because we have only one earth, we don't have many earth. Can you think that if our demand will grow by four folds or three folds, so can we have more earths? No, we have only one earth, remember. So we have to use the resources in very controlled or the efficient way, and not only that, we do not harm the environment. Like I said, there are also geopolitical implications to the material, even if there are material abundantly available in other countries, but they may not be available to us. Just for example, if we have noticed or tracked this news during lockdown time, there was a semiconductor crisis for the auto industry. Where this semiconductor crisis came from? Taiwan is one of the largest manufacturer of the semiconductors in the world, and because of this pandemic time, all this shifting, people wanted to buy more laptops, more mobiles to remain connected instead of the cars or the automobiles. So the manufacturing company shifted their productions to the semiconductors for the laptops, computers and mobiles, and the automobile industry started facing problem. Some of the auto companies have even deferred their production for automobiles till the time they get, because the new automobiles are coming with lot many semiconductors, modern design, intelligent designs, and even one OECD Environment Working Paper indicates that by 2060, India could be a largest importer of goods or services or the technology. So we require lots of material, and that is why we have a pressure to adopt the circular economy in our production and the consumption pattern. But the barriers are also there for circular economy. It is not very easy that, okay, this is the circular economy, start practicing that tomorrow onwards. It has some internal limitations, some technical limitations, market-oriented limitations. Nobody wants to buy the recycled plastic or recycled metal, then regulatory problems, and then economy and the financial, of course. So I said that resource efficiency and circular economy are two different concepts, but ultimately they merge here, that we have to use resources very efficiently, as well as we have to recycle the product at the end of its life. Again, the circular economy principle simplified version is the eliminate waste and pollution, circulate products and material, and regenerate the nature. Again, trying to give some more news headlines. Here it says like the material demand we can produce more and more material or the products, but what will happen, we have to consider the environmental degradation whenever we are producing various things for our country. And if you see this plot, this is the business as usual model versus the circular economy model. See the landfill, see the material requirements. So ultimately, because of this, government of India is also started acting, and very aggressively rather, what I would like to emphasize very recently, to so that our country doesn't have much dependency. Atmanirbhar Bharat. Atmanirbhar Bharat is not just material, this import related thing, but the every aspect of Atmanirbhar Bharat. Lot many things are happening there. We don't have to import the technology. We don't have to import the material. Whatever resources we have to manage that. So if I say the circular economy in metal sector, this is the concept from the OECD again. So like for any material to be used in downstream value chain for say for a metal, you mine the ore, you upgrade the ore and process it and supply the material in the manufacturing system and to the consumer. So the primary sources or the secondary sources, like primary sources are ore, of course, that you extract from mother nature, and the secondary source could be the scrap. Upgrade, you concentrate, beneficiate the ore, and then upgrade for a secondary material could be sorting, because it is always a multi-material product, and then do the smelting and supply the material to the manufacturing system and ultimately to the consumer. Consumer may return it or reuse it or repair it or remanufacture it, or ultimately it can be given for recycling. Suppose, consider a refrigerator. It has a body part made of granulized steel, the foams, the tubes, steel, handle, base, internal parts, evaporator, small components, wires, lot many material. It is a multi-material product, one refrigerator. If you see a washing machine, it is a multi-material. What is happening? Every household wants a new washing machine. Every household wants an air conditioner. Every household wants a TV. We are disposing of these products also very frequently. So these products are being dumped as a scrap, which has lots of copper, lots of aluminium, and lot many other metals. And this needs to be recovered or recycled. Just like the government has started the auto scrapping facility. But what happens if you shred one car directly without thinking of the material mixing and all those things, will be again wasting energy to while sorting the material, plastic, zinc, copper, aluminium, steel, and whatnot. So if the simplified system, like we can easily dismantle, take out, this is a multi-material model of circular economy for a product, like we take out, this is the power drill or hand drill. If you can simply dismantle the product and sell the specific or give the specific material for specific use or for recycling, the job will be much easier. Like हमारे मोदी जी कहते हैं कि recycling, reusing, eliminating waste and improving resource efficiency must become part of our lifestyle. So the government is, as I said, like this is one of the Paris Agreement commitment where various sustainable development goals are there. This sustainable production and consumption is number 12, and the government has many schemes or the plans for that. Even the effect of COVID is assessed regarding that, and this area like renewable energy and alternative energy has emerged as one of the principle for sustainable production and consumption. And the circular economy in metal sector, these two documents have been published recently. Circular economy in metal sector, this is published by Ministry of Steel in association with Niti Aayog. This document, National Non-Ferrous Metal Scrap Recycling Framework of 2020, is published by Ministry of Mines. So this circular economy in metal sector, as I said, like government is working very aggressively. They formulated 11 committee for circular economy in various sector, and this scrap metal, which includes both ferrous and non-ferrous metal, the responsibility is conferred to Ministry of Steel. This Ministry of Steel published this report with various targets or objectives, where they have done the mapping of waste generation in entire chain from mining to primary production, secondary, everything, R&D needs, everything, what is the government support required, and various challenges in circular economy for aluminium is like it generates lots of red mud, spent pot linings, dross, and these are some of the recommendations for aluminium sector, like mandating dry stacking of red mud to avoid the environmental disaster, mandating use of red mud, spent pot lining in cement industry. Yesterday we had a consultation meet with the primary aluminium producers and the cement industry, where according to this recommendations we were to arrange the consultation meet with stakeholders, and the issue is like okay, primary aluminium manufacturers or producers are producing red mud. They are somewhere in some remote location, we can say, and the cement industry is somewhere else. So, okay, the red mud can be used in cement manufacturing, but who will bear the cost of transportation from the refinery side to the cement industry or cement factory side? So that is a kind of a concern when we implement the circular economy. So certain barriers are of course there that has to be looked upon. Likewise, there are challenges for the copper and the brass, like we have to utilize the overburden going for ore, like the copper concentrate or the copper concentration is ore is very less. So to produce the copper, we use dig lots of resources from earth, overburden, and simply dump it. But it has to be used in some way. Recently, some of the industry or the copper industry specifically, I would say, started using overburden as a the building material. They started refining the sand from there. Because again, sand is a limitation for the country. Whole country, everybody wants a house for them. The government wants a house for everyone. This is the scheme. But where will the sand come from? Where will this cement will come from? So that is what the government thinks, that if the industrial symbiosis, what I talked about, like the waste from one industry could be the resource or the source for another industry. So we can achieve this, and that is what this circular economy or these documents talk about. And these are the various recommendations, like digitalization of scrap and waste management, setting up of recycling zones, building robust reverse logistics system, strengthening research and knowledge base, industry status, and so on. And role of various stakeholders is very important, like government is policy for formulating policies, regulatory bodies are controlling the activity, and academia specifically, and R&D. They are the know-how or the knowledge producers. So we can act together, we can work together to see how one refrigerator, one air conditioner, or one LED TV can be recycled, because there in one circuit board you'll find many metals, small pieces. How we can segregate, how we can sort them. And this is the action plan based on that circular economy in metal sector. These are the action plan, actually implementable activity, that what is assigned to JNARDDC, Jawaharlal Nehru Aluminium Research and Development and Design Center. So number one is like zero waste management policy in line with zero discharge to encourage utilization of various waste and improving sustainability in metal sector. Developing guidelines for environmentally sound management of red mud, and specific timelines are given to produce these documents or the guidelines. Guidelines by CPCB for mandating use of spent potline in cement industry as an alternative fuel. Ministry to carry out its scoping and have a stakeholder consultation for extended producer responsibility provision for different waste and scraps for efficient utilization. Like so far we know about the extended producer responsibility regarding the lead acid batteries. You want to buy a new battery, you hand over the old battery, it is their responsibility to collect it back and you buy the new one. So this kind of a concept will be coming very soon to many more areas, and Niti Aayog has suggested that the automobile area can be taken as a first example for EPR provisions. And JNARDDC will do the stakeholders consultation with OEMs regarding this subsequently, and series of conferences on resource efficiency, circular economy to spread the awareness about this resource efficiency, circular economy. That is what I was talking to Dr. Naidu, like why I picked up, because we have to spread awareness about this NITI Aayog section plan, or spread the awareness with young minds about circular economy, so that they start writing proposals, or they can pick it up as their research topics, PhD topics, to how to recycle a particular product, how to improve the quality of the recycled metal, like that. And then we are also looking for exchange programs with international bodies to bring the best available technologies in the country. And the next document, this is the National Non-ferrous Metal Scrap Recycling Framework 2020. This was published by Ministry of Mines, and the JNARDDC is under this framework only. We are nominated as a Metal Recycling Authority. So the objective is to promote organized recycling ecosystem and work towards economic wealth creation, job creation through metal recycling, and shift towards a circular economy in the coming years. As this is some background about this Metal Recycling Authority. It was published in 2021, and vision is to organize non-ferrous metal sector, because it is considered mostly that non-ferrous, as I mean the recycling sector is not well organized. Improve quality of the recycled products, and improve the visibility and support to the recycling industry. So our envisioned work is to standardize the recycling practices, to devise and maintain data bank of recycling value chain, and inspection or the review of recycling units, assist them with the technology and infrastructure. So these are the various roles and responsibilities. So we have come up with a draft document, the guideline for non-ferrous metal scrap recycling. Currently we are working for 4 metals: aluminium, copper, lead, and zinc, where we have to develop the standards, how it can be processed, what should be the minimum infrastructure, what should be the minimum recycled content. Even the government is thinking with reference to this framework that minimum recycled content guideline will be considered, so that any manufacturer will have to use certain recycled metal of aluminium, copper, lead, and zinc when they are making certain products. So it will be having some type of logo that, okay, this material contains 10% recycled material, 20%, or whatever percentage the manufacturer uses. So the green labeling of the product, all these things are coming up very soon. And for students some circular economy ideas, like one mobile has reduced lot many devices. You can do lot many things with mobile. It has reduced uses of paper. So not only the material wise we think of circular economy, but the other way also, like if you can substitute 10 devices with one device like mobile, so you reduce the material, you reduce the requirement for the energy to produce 10 products. And then machine to machine communication, it again speeds up the communication. Cloud computing, you don't require 10 computers, you can have 10 monitors and go for cloud computing. That will serve your purpose. Then the social media, after this, so lots of social media platforms, it has reduced the paper requirement for newspapers. Data analytics can tell what customer is looking for, and all these things are ultimately helping the circular economy. Modular design technology, like is happening. If a certain part of mobile is not working, you just go take out that part and replace that. Modular mobiles kind of thinking. Advanced recycling technology, life and material science technology, trace and return system, 3D printing even is considered as a CE idea, a circular economy idea, because you have a less wastage of the material and less wastage of energy, because in very short time you're able to produce the material uh, in the very net shape, near net shape, or very exactly same shape, so that the scrap or the machining and all these operations are minimized. So these are some of the ideas that the students or the PhD students can start thinking in this direction and take up the research work. So that's
Thank you so much, sir. So your voice is not audible, sir. Yeah, it's not audible. Thank you so much, sir, for your nice lecture and talk. Now I request the participant, if you have any query, you can ask directly to sir, because you can unmute yourself and you can ask the question. The participants can ask directly.
I hope, Dr. Naidu, that I am able to convey the message of circular economy and how the manufacturing system, or how the material system, how the overall system will be affecting our future production techniques. You see, the lot many things are being talked about the IR 4.0. Even people start saying that IR 5.0 is already there. So there has to be some kind of a synchronization, some kind of thought given to any of the manufacturing, any of the material processing technique, that has to be ultimately in this direction, the concept that we do not harm the nature, we do not waste the material. So anyway, the students can always post their question. You may share my contact details with them, and even we invite to work jointly in some aspects, if possible, to do some specific research work in this direction, because one of the action plan or the recommendation is also to support the R&D. I mean, of course, the government system will finance or support more R&D projects in the circular economy related activities. So we can think of collaborating somewhere in this direction. So that's all for the timing. I think somebody has
Yes,
raised.
sir. Yes,
Yeah,
sir. Yes, sir.
yeah, please.
Bal sir, please ask the question. Dr. Bal sir. Dr. Bal sir. Dr. Bal sir, are you here? Okay, sir. I have one question, sir.
Sure.
Sir, as a faculty, I mean, like as a academician, so what are the opportunities at the JNRDC is looking for? I mean, like in R&D sector, R&D projects.
We collaborate with academic institute in various ways, like we can do joint projects. Recently, we started 3 projects with academic institute. This metal side specifically, I'm talking about. Other departments are also doing. Like we started working with IIT Gandhinagar, then Munjal University, and Sri Ramakrishna Engineering College. So these institutes have recently formulated some proposal that is granted also. So we can work with NIT Raipur also. We can formulate some proposal, certain direction. We have some facility like extrusion press, casting facility, and of course the characterization outside also. So this is the one area like we can go ahead for joint research projects. We can write joint proposals, submit it to various DST or Ministry of Mines or other agencies. And the second area of is like we give project works to masters or the PhD students as a part of their coursework. They can come here, do some part of the activity here where we can collaborate, we can guide them. And we also invite students for their vocational training and short visits also. Apart from their regular curriculum, they can come here. I mean, as a part of their regular curriculum, they can come here, and like for the final year students, they can come here, do some project work, and the second year or the fourth semester students can have planned their short visits, so sort of thing. So this is how we interact with the academic institute.
Thank you, sir. Thank you, sir. Bal sir has touched a question. So due to his mic issue, he wants to know that the scrap disposal policy in line with circular economy. And Government of India has got one agency, MSTC.
Okay, it's in the text. I have my question. Just wanted to know the scrap disposal policy in line with circular economy. Government has got any agency MSTC? Yeah. There is one agency that collects the scrap, and this MSTC has also joined hands with Mahindra group, and they have come up with the Zero Recycling, CERO, Zero Recycling group. And this Ministry of Road Transport and Highway, recently they published one vehicle scrappage policy. That vehicle scrappage policy gives the feasibility or the option for registered vehicle scrappage system. So this MSTC and this zero recycling is there. Maruti is coming up with the vehicle scrappage system. So this is kind of organized recycling or organized scrap collection system. So this is as on date very limited in the country, but it started and we'll have many more, because this Metal Recycling Authority has the various plans to start various actions or the systems where similar thing can be implemented for various scraps. I hope I am able to convey what Mr. Bal is looking for.
Sir,
Okay,
Yes, sir,
great.
is already given
I have a
information.
question.
Sure,
I
sure.
have a query.
Yeah.
How circular economy can be managed for e-waste in your industry?
Sir, circular economy for e-waste, there is already one published guideline, but
Sir,
still it's a challenge. It is seen as a challenge because, as I said, you just dismantle one TV and you will find it's a multi-material. Lots of chips are there, and even some materials are not consumed. So the requirement is why don't we develop a process, why don't we take up this as a challenge and work towards separation of material, because the slides what I have shown regarding the refrigerator and the TV or washing machines, these slides were shared by one of the scrap collector from Jaipur. They want to venture into the recycling of this electronic waste. They're facing of the problem like how to segregate small metal. So the technology or the processes needs to be developed. That is what I'm thinking, like if we can join hands together, we can write a proposal to Government of
yes,
India
sir.
and can have a working, I mean, start working in this direction.
Yes, sir. One of my PhD scholar is working on this.
Great,
So
great.
this question came into my mind.
Okay.
So if you permit, then I'll send him to you so
Most
that
welcome, sir. Most
yeah,
welcome. Yeah.
yeah, so that he can explore something about his research work.
Sure, sure, sir. We'll be really
Thank you very
happy
much,
to
sir.
help you and your student.
Thank you, sir.
Most welcome, sir.
Any more questions? So thank you so much, sir, for giving a very elaborative way of on circular economy in the main sector of metal sector. So, and Naidu sir, can we conclude now? And
Yeah,
So,
Jagdish,
yeah,
please
yeah,
continue, Jagdish.
yeah.
yeah.
Thank you so much, sir, again for presenting your insights on circular economy in ferrous metals, in the non-ferrous metal sectors,
Yeah.
with respect to new perspective. And dear participants, sir has highlighted majorly on technological evolution of different materials, like maybe oxide, aluminium, smelter, and other. And also he has highlighted about circular economic transition on different metallic materials, like and also transition in its benefits like reduction of extraction of virgin natural resources, reduced environmental pressure, new economic and employment opportunities, energize with a low carbon transition. And sir is also highlighted on benefits of sustainable development in production. That is one of the important in the current days requirement of any industry. And in fact, circular economy on different metals and non-metals needed for the present and future also is highlighted by sir. And finally, he has shown some of the circular economy's ideas for our MTechs and PhD scholars, how the MTech and PhD scholars can collaborate in the with JNRDC for doing their activities. And finally, he has given opportunity to the academics to club with JNRDC for carrying out different R&D projects. So thank you, sir. On behalf of organizing team of AMEIIM 2022, and I will thank you for being with us today. And we truly will express our gratitude also to you for accepting our invitation and taking out your precious time. for sharing your vast experience in the area of circular economy in the metal sector, in Indian perspective. So thank you once again for being with us, sir.
Yeah, thank you, Dr. Jagdish, and thank you all the faculties once again. And Dr. Naidu, thank you so much for
Yeah.
inviting me, and look forward to continued interaction on this particular topic.
Sure, sir,
Yes, sir.
definitely.
Thank you very much, sir.
Bye bye.
Bye,
Bye bye.
sir.
Bye, sir. We'll see you, sir. Bye bye.
Yeah.
Okay, I'm signing off this call.
Yeah. So, dear participants, you can join your respective session for oral presentation. The link is already been given and shared in the WhatsApp as well as in the email. We'll meet in the respective session only. Thank you once again.
Yeah, thank you. Bye bye.